The human visual system is a wonder of nature. Each human eye contains approximately 6 million color-sensing cones and 120 million rods responsible for night vision. The captured images pass through the optic nerve, formed by 1 million nerve fibers. The brain analyzes information like size, distance, shadows, and texture to create our three-dimensional perception of the world. It also compensates for blurry peripheral vision, filling in details where there are none, which is absolutely brilliant. Over 50% of the cerebral cortex is dedicated to visual processing. According to Professor David Nill from the University of Rochester, from childhood, our brain learns how to construct a three-dimensional environment by interpreting visual sensory signals like shape, size, and occlusion. That is, how closer objects obstruct the view of more distant objects. We learn to see, says Professor David Nill. The human visual system is the model for computer vision, a field of artificial intelligence that enables systems to capture, process, and extract meaningful information from images. It began in the late 1950s with Frank Rosenblatt, who invented the perceptron, a mathematical model for a human neuron. The perceptron was able to classify simple visual patterns, like differentiating geometric shapes. Now let's jump to the modern era of computer vision. Convolutional neural networks, or CNNs, play a crucial role. CNNs were directly inspired by the structure of the human visual cortex. Just as our neurons connect to form circuits that interpret visual patterns, CNNs have layers of artificial neurons that learn to detect specific features in an image. These layers become increasingly complex as we go deeper into the network, allowing the CNN to recognize full objects and perform advanced tasks like facial recognition, object detection, and even be integral parts of autonomous vehicles' vision. As algorithms draw more inspiration from human neural mechanisms, like massive interconnectivity and unsupervised learning, computer vision comes closer to the impressive flexibility and generalization of our visual perception.